In a previous lesson, we introduced algebra and we said that in algebra, we follow the same rules as normal number sentences. We can add them, we can subtract algebra, we can multiply algebra, and we can also divide algebra. So they behave exactly the same as normal numbers. We have pronumerals which we know as letters or symbols. However, there are certain rules that we have to follow. Let's understand these rules. Today, I'm going to show you how to add and subtract algebraic expressions, meaning number sentences that have pronumerals. We call them algebraic expressions. Before we start, we need to know something called like terms, because we can only add or subtract like terms. Very important concept. We can only add or subtract like terms. I've seen students, they get confused and they start adding everything up and subtracting everything in algebra. No, you have to be careful. You can only add or subtract like terms. Now, what are like terms? Let's see what we mean by like terms. We're going to go through each example and you're going to see what like terms are. Like terms meaning that the terms have the same pronumerals. Now, what is a term? This is a term. 2a, 5a, 7b, b, 6x, 3x, xy, 4xy, 3a squared, 5a squared. These are all terms. To add or subtract, we have to make sure we have like terms, meaning the same terms. Terms that have the same pronumerals. Very important. If you want to learn anything in algebra that is so important, it's this. You have to only add or subtract like terms. Let's see what like terms are. Now this is a term, 2a, and this is 5a. Are they like terms? The answer is yes. Why? Because they have the same pronumeral. A and A. So 2a and 5a. I like to tell students that think of it this way. 2 apples and 5 apples. You can add them up. 2 apples, 5 apples. A for apples. So a pronumeral and a pronumeral, they are the same here and here. Therefore, 2a and 5a are like terms. So you can add them up. Are these like terms? We have 7b and we have b. Now b really means that there's a 1 here. 1b. So when you see a b, it's not just a b, it's actually 1b. Are these like terms? Do they have the same pronumeral? That's the question you ask. Do they have the same pronumeral or pronumerals? In this case here, yes, they have a b and a b. Therefore, 7b and b are like terms. Now, you answer this one. 6x and 3x. Are they like terms? What do we ask? Do they have the same pronumeral? The same pronumeral, we have an x here and an x here. Yes, 6x and 3x are like terms, meaning they can be added and subtracted. Looking here, we have xy is one term and 4xy is another term. Are they like terms? We ask, well, do they have the same pronumerals? We have an xy here and an xy here. Yes, they are like terms, so we can add them up if we need to. 8ac, 2ca. We have a term here, 8ac, another term, 2ca. Are they like terms? Let's see. Do they have the same pronumerals? We have ac here and we have ca here. They have the same pronumerals, however they have been swapped. AC, CA, doesn't matter. As long as they have the same pronumerals. The order does not matter at all. AC, CA. And we learnt before that AC means A times C. And C times A, CA. So we're multiplying 4 times 3 and 3 times 4, it's the same answer anyway. You get 12. 4 times 3 is 12 and 3 times 4 is 12. So the order does not matter. So AC, A times C, CA, C times A, it's the same. Therefore, as long as the pronumerals are the same, there's an A here and an A there, a C and a C, yes, they are like terms. 8AC and 2AC or 2CA are like terms. They can be added or subtracted if we need to. Here, 7GX is one term. There it is. And XG or 1XG is another term. Are they like terms? Well, do they have the same pronumerals? GX, XG, yes they do. The order does not matter. GX here and XG there. Yes, 7GX and 1XG are like terms. Coming here, we have 3A squared is a term. 5A squared is another term. Are they like terms though? Well, do they have the same pronumerals? A squared and A squared. Yes, they have the same pronumerals. Therefore, 3A squared and 5A squared are also like terms. BC squared is another example. And we have 6BC squared. These here, we ask, are they like terms? Well, we have BC squared here. We have 6BC squared here. So we have a BC squared and a BC squared. Yes, BC squared and 6BC squared are like terms. They can be added or subtracted. Last example, 4XYZ is a term and 2YXZ is another term. We ask, are they like terms? Well, XYZ here, they're the pronumerals. YXZ, we have an X, yes, we have a Y, yes, we have a Z, yes. Therefore, 4XYZ and 2YXZ are like terms. That means we can add them or subtract them if we need to. Very important rule. Like terms, we now can see what like terms are, and I want to test you. I'm going to put some here and see whether you can figure them out yourself. We have 4B and 3B. Well, do they have the same pronumeral? Yes, yes, then they are like terms. What about this one here? 4C and 5BC. Well, are they like terms? We have a C here and we have a C here. But here we have a B and here we don't have a B. Therefore, these are not like terms. This is a term, this is another term, but they are not like terms because the pronumerals are different. What about this one here? Five B squared C and C squared B. So we have a term here, 5B squared C, another term, C squared B. Well, are they like terms? We have a B squared, and here we only have a B. While here we have a C, and here we have a C squared. They are not like terms. Why? Because in reality, 5B squared is BBC, but we write it in simpler form, and C squared B is really CCB. So they are actually different. They look the same, but don't get tricked with the squared. The squared here is on the B times B, and the squared in this term is on the C times C. So it's very important to differentiate. Be careful, don't get tricked by the squared. It has to be exactly on the same pronumeral. Here it is actually different. So now we can tell what are like terms, and we can differentiate between like terms and the terms that are not alike. Now we can show some examples of addition and subtraction of like terms in algebra. Let's do that now. In these examples, we are now asked to collect like terms. When we're asked to collect like terms, it actually means add and subtract the like terms only. Remember, the rule is we can only add or subtract like terms. Let's get started. This example here, 2a plus 4a. Are they like terms? Well, do they have the same pronumerals? A and a. Yes. 2a plus 4a, 6a. It's like saying 2 apples plus 4 apples. We have 6 apples. Like terms, meaning they have the same pronumerals. That means we can add them because we can only add or subtract like terms. Very, very important rule. 20x, take away 5x. Are they like terms? Well, we have an x here and an x there. So yes, they are like terms. 20 take away 5. 15x. 20x, take away 5x, 15x. In this example here, we have 4xy plus yx. Now, are they like terms? Because we can only add or subtract like terms. xy, yx, yes, they are like terms. The order doesn't matter as long as the pronumerals are the same. X here, x there, y and y, they are like terms. Now, 4xy plus yx. We know that here there is an invisible 1. Don't forget that. Make sure you remember there is an invisible 1. 4 plus 1, 5xy. 4 plus 1, 5xy, or 5yx, doesn't matter. It's best to write it in alphabetical order. xy, so 5xy. 4 plus 1 is 5xy. Here we have 3x plus 6x. Are they like terms? Yes, they are. 3 plus 6, 9x. 3x plus 6x, 9x. It's like saying we have 3 x's on one side and 6 x's on another side. Altogether, we have 9 x's. Here, 7x squared y squared plus 6y squared x squared. Are they like terms? We have an x squared and x squared, yes. Y squared and a y squared, yes. That means we can add the 7 and the 6. We have 13x squared y squared. Now we have 3 terms. We have a term here, another term there, and another term there. And we are asked now to collect them so we can add or subtract them. Do they have like terms? Let's see. A squared, a squared, a squared. Yes, they are all like terms. We can now collect them. 6 take away. Now we said in front of the a squared there is an invisible 1. 6 take away 1 is 5. 5 plus 3 is 8a squared. So 6a squared minus 1a squared is 5a squared. 5a squared plus 3a squared is 8a squared. This question, 5x take away 3y, they are asking us to collect like terms. Well, let's see. 5x take away 3y, hang on, these aren't like terms. We have an x here, we have a y here. They are different. They're not like terms, so we can't actually collect them. So guess what? The answer is the same as the question. Nothing changes. 5x take away 3y. That's as simplified as it gets. This here, you need to make sure you switched your brains on and you are concentrating. 12g squared minus 4g plus 2x. Well, any like terms? We look and we notice there is no like terms. This has a g squared, this term has g squared, this term has g, and this term has an x. There are no like terms whatsoever. So that means we can't collect like terms. The answer is the same as the question. Nothing changes. And again, very important, G squared is not the same as G. Very important. G squared means there is G times G, while here it's just G. So these are not like terms. That means we cannot collect them. The answer is the same as the question. Nothing changes. Last one, we have 6b take away 3x plus 4b. Are there like terms? Well, there is a 6b, there is a b here, and there's a 4b there. So these are like terms. We can add them or subtract them. Well, we need to realize something. We notice that this minus, who does it belong to? It belongs to the 3x. Very important for you to realize that. It's 6b plus 4b. The symbol always sticks. It belongs to the term after it. Very important rule. The symbol belongs to the term after it. So it's 6b plus 4b. The minus belongs to the 3x. So 6b plus 4b, 10b, and minus 3x. 6b plus 4b, the plus belongs to the 4b, that minus belongs to the 3x. So 6b plus 4b is 10b, take away 3x. We can't solve it any further. We can't simplify it any further because these are not like terms. This is now the basic addition and subtraction of algebraic expressions. We are collecting like terms. As you can see, very important to distinguish what is a like term, what isn't a like term, so you know how to add and subtract. We can only add or subtract like terms. Remember that all the time.